Happy learning! Today we're talking about business applications using quadratics. Okay, so let's start by talking about profits and revenues and costs. Recall that the revenue function is revenue equals the price of the object times the number of units sold. Okay, but price does not have to be constant. It's possible that we want to give a discount to somebody who buys a lot of our product. Maybe it's $10 for 1 unit, but if you buy 20 units, we'll sell them for $8 a piece. So it's possible that price isn't constant. And that's what we're going to look at today. So for example, we're going to use little p for price. So if our price function is 300 minus x, right? So this is saying if we sold 1 unit to somebody, we would charge $299. If we sold 100 to them, that we would charge $200 each. Okay, so if our price function is this, then our revenue function is equal to our price function times the number of units sold, which is x. And we can distribute this to be negative x squared plus 300x. Right, so in this situation, our revenue function is a quadratic. And so we're going to be looking at these types of examples today. So let's look at an example. Suppose that the cost of manufacturing X units is given by our cost function. C of x is equal to 2x squared plus 100x plus 3600. And the price function, so the amount that we're going to sell our unit for, so suppose our price function is given by p of x, little p of x, equals 500 minus 2x. So this is the cost for the business owner of X units. This is how much we will sell the product for if you're buying X units. So what we want to do is find the number of units that gives the break-even point. For the product. All right, so pause the video, try this on your own. And then when you're back, we can work through it together. Okay, so welcome back. The break-even point. The break-even point is when our cost is equal to our revenues. We need our revenue function. Our revenue function is our price function times the number of units sold, which is x. All right, our revenue function distributing this x is negative 2x squared plus 500x. We want to find when our revenue function is equal to our cost function. That's the break-even point. All right, so let's take our revenue function. We're going to set it equal to our cost function. To solve this equation, we want to get all of the terms on one side. All right, so I'm going to bring these terms over to the other side, and we have 0 equals 4x squared minus 400x plus 3600. All right, and we can try to factor this. I think the first thing we should do is divide both sides by 4. Just to make our numbers a little bit smaller and easier to work with. All right, so we have 0 equals x squared minus 100x plus 900. All right, and we could solve this quadratic either using factoring or the quadratic formula. I'm going to factor. So we need two numbers that multiply together to give us 900, that add together to give us negative 100. And so that's negative 10 and negative 90. All right, and so we have two break-even points. X equals 10 and x equals 90. And so what would this look like graphically? If we were to plot our revenue function and we were to plot our cost function, the revenue function, right, we could use Desmos, but you could just trust me, looks something like this. And our cost function will look something like this. Right, how do I know that? The revenue function is a parabola. Where's our revenue function? Here. Is a parabola facing downwards, so it's going to have this shape. And our cost function is a parabola facing upwards, so it's going to have the U shape. So it's going to have this general shape here. And so our first break-even point is when the two curves cross for the first time, and the second break-even point is when the curves cross for the second time. All right, so if we're between these two values, which we said are 10 and 90, this is the profit. This is where we're making profit because our revenues are greater than our costs. All right, so if we sell anywhere between 10 and 90 units, we're profitable. All right, so let's just continue this example. Let's find, right, we see that our revenue function, is a parabola that's opening downwards. So its vertex is a maximum. So the maximum revenue how do we find that? We need to find the vertex of the revenue function. So it occurs at its vertex. And so that means the vertex is when x equals negative b over 2a. Negative b is negative 500. Over 2a. Which is 125 units. Okay, so our drawing is actually a little bit misleading. It should look more like this. Our vertex is to the side. Okay, our vertex actually occurs at a point when our costs are greater than our revenue. Okay, so just because we maximize our revenue doesn't mean we maximize our profit, right? So when 125 units are sold, cost is actually greater than revenue. So what does this show you? It shows you maximizing revenue is not the same thing as maximizing profit. So sometimes you have to sell less to make more, which is what this shows here, which is a little bit surprising, at least to me. So continuing with this example, find the number of units that maximizes profit. And we're going to find the maximum profit. All right, so we need to find the profit function, and we're going to find its vertex. It's as simple as this. All right, so remember, our profit function is our revenue function minus our cost function. Our revenue function is negative 2x squared plus 500x. And our cost function was given to us, 2x squared plus 100x plus 3,600. Okay, distributing the negative and combining like terms, we get minus 4x squared plus 400x minus 3,600. This is our profit function. All right, and we want to maximize our profit function, so we need to find the vertex of the profit function. All right, so to find the vertex, we know that x equals negative b over 2a. Negative 400 over 2 times negative 4. Okay, and this is 50 units. So our profit is maximized when 50 units are sold. And what is our profit? Well, we just need to figure out what P of 50 is. So we take our profit function and we sub in x equals 50. All right, and so when we do that, we could just type this into a calculator, and our maximum profit is $6,400, or whatever our units are. Okay, and note this 500 units happens to be halfway between the two break-even points, right? The first break-even point was 10, the next one was 90. The halfway point is 50 units. So that's just one of the properties when we have quadratics. All right, let's look at another example. When we first looked at supply and demand, we assumed that the supply and demand curves were linear. And that was just because it's easy to draw lines. It's not really how it works in real life. The curves are typically curves. And so let's take a look at an example. If the demand function for a commodity is given by price times quantity plus 4 equals 400. Okay, if we were to plot this, it would have kind of this shape, a downward curving shape. But we don't really care about the graph right now. So if the demand function is given by this, and the supply function is given by 2p minus q minus 38 equals 0, let's find the market equilibrium. Okay, so remember what the market equilibrium is. It's when our demand curve and our supply curve intersect. Okay? This, if we were to graph this, this is actually a line still, but that's okay. So this is kind of, if we were to plot these, this is what it would look like. We have our demand curve, we have our supply line, and we want to find the quantity and price when these two curves intersect. Okay, and so there's a number of ways we could do this. Our best method, I think, is let's solve for quantity in our supply equation, and then we're going to substitute that in for our quantity in our demand equation, and then we'll reevaluate from there. All right, so demand says that P times Q plus 4 equals 400. Supply says that 2P minus Q minus 38 equals 0. Another way to say that is that Q is equal to 2P minus 38. We're going to sub in this quantity for Q. All right, so we have P times 2P minus 38 plus 4 equals 400. P times 2P minus 34 equals 400. And now let's distribute and bring everything to one side, right? If we're going to try to factor or use the quadratic formula, you better have a 0 as one side of your equation. All right, so we have 2P squared minus 34P minus 400 equals 0. And just to make our life a little bit easier, I'm going to divide everything by 2. P squared minus 17P minus 200 equals 0. Let's try to factor this. P. One of these is going to be a plus, one's going to be a minus because they multiply to a negative. And we need them to be 17 apart. So how can we multiply to 200 and have the numbers be 17 apart? Well, that's 25 and 8. All right, and so this gives us that our price is -8 or 25. One of these prices doesn't make any sense, right? It doesn't make sense to sell a product for -8. So 25 is our market equilibrium price. How do we find the market equilibrium quantity? Well, we just sub this into either one of our equations and solve. Let's solve it into this one. because we already have quantity in terms of price. So our quantity is 2 times 25 minus 38. And that gives 12. So we're going to sell, the market will have 12 units sold at $25 a piece. Okay? So I hope you enjoyed today's lesson and learned something about how to apply our techniques from quadratics to these business and economics questions. Let me know in the comments if you have any thoughts. All right, bye-bye.